everybody. So I've got a few more kids that are at home right now, whether you're quarantined or sick or out of town, you just missed today. I feel that the lesson today can be a little bit confusing. So I want to kind of walk you through it. All right. So today we did an online simulation. And what I have right now is here is our Canvas page. And I'm going to scroll down because right here we're on Unit 3. And I'm going to go ahead and go to Assignments. And this is the online simulation link. All right. So you can get to it here. Or let's go ahead and back this up again. And I'm going to go to the daily log. This daily log will be very, very helpful if you're home for numerous days. So here's October 1st. And it says, today you're going to work on page 5 and 6 in your notes packet. You'll be using the online ecology simulation to fill out. And it tells you don't worry about filling in the prediction portion of the table. So you can leave that out. You're going to manipulate exactly what it says you to do in each step and then record your results. So, and same thing, the link for the simulation is here as well. So I'm going to go ahead and click on that. All right, and this is where it takes you. Move this over just a little bit. And it probably would be helpful if I also showed you where we're at exactly in the notes packet. So I'm going to scroll to, like we said, page 5 and 6 are right here. So you don't need to worry about this prediction part. You can just cross this part out. You won't need it. And we're right here. We are going to introduce plant A and plant B into our ecosystem. And then we're going to run the simulation. So I'm going to go ahead and put that down for a minute. So the way you can tell what is what is if you put the mouse over it, it tells you what's going on. So I'm going to introduce plant A. I'm going to introduce plant B. Okay. Oh, sorry, it was already on. So make sure you hit the all off button. So there's my all off button. All right, so I'm going to introduce plant A. I'm going to introduce plant B. Excuse me. And then I'm going to go ahead and run that. So we're going to see what happens. We'll go ahead and pause it. We're about day 39. And then we're going to look down here at this graph. So plant A, okay, right here, this top green one. Plant A, is it going to tell me? I know it tells me plant B, but plant A is in the same place. So plant A started with 5,000 plants. And same with plant B, it started with 5,000 plants. And then after we get up to here, after we get to day 35, now we're looking at 10,000 plants for plant A. And we're at 0 plants for plant B. So now we're going to go ahead and look back at our table. So the starting population for plant A is going to be 5,000. And the starting population for plant B is at 5,000. And then after they had time to grow, mature, reproduce, grow new seeds, plant A, the ending population got clear up to 10,000, and plant B, the population was at 0. So let's go ahead and look at that graph again. So they both started the same place. Then A got to 10,000 and B got to 0. So we're going to answer a couple of these questions. What assumptions does this model make about how the plants get along together, as well as the general terrain of the ecosystem? So knowing what happened here, that one plant dominated over the other, it goes to show that it suggests they probably didn't get along very well. They probably have different requirements. When it comes to the terrain, the fact that plant A was so successful lets you believe that there was a lot of good nutrients in that ecosystem for plant A to flourish. Where plant B, maybe the ecosystem, the nutrients, the amount or what was in it wasn't sustainable or wasn't enough for plant B to stay alive. And so it could show that the ecosystem definitely favored plant A more than plant B. All right, so if we pull this back up, number 2, do you find one producer to be dominant? Yeah, absolutely. Plant A is dominating over plant B. Why might one producer be dominant over the other? And it's kind of like we mentioned before that one could be dominant over the other simply because the nutrient levels are different. Maybe plant A grows extremely fast and reproduces seeds a lot faster, so therefore it's creating new ones, where plant B takes a long time. So lots of different reasons, and you could just pick what fits or what you thought of first. So now we're going to go on to the second step. You leave plant A and B where they're at, but now we're going to add a herbivore. And once again, don't do the prediction. You can cross this out. So let's go ahead and go to our herbivore. So I'm going to click on this herbivore A. Now you decide what it's going to eat, but keep in mind, plant B is at 0. So even if I say eat plant B, it doesn't matter. There's no plants for it to eat. So I'm going to put it's going to eat plant A. And then I'm going to go ahead and hit run. And let's see what happens in simulation. I'm going to pause that. It looks close to where it starts to level off. And that's where you want to stop the simulation. So once again, we'll go back to our table. This is where they started. Plant A started at 10,000. Plant B started at 0. And the rabbit started at 1,000. So what happened when we got clear to the end? A dramatically dropped. B increased and then dropped. And the plant is still dead. So we shouldn't be surprised to see the rabbit population skyrocket here and the plant population plummet, because there's so many rabbits that are eating the food so quickly. Then the food drops so low that the rabbits had to follow suit and drop low as well. Plants increase, rabbits increase. Plant decrease because the rabbits increase. So once again, it's just kind of giving you an idea of what happens when you introduce one species into an ecosystem, how drastically it can change it. So we'd go back to our table and say plant A started at 10,000 and ended at 3,298. Rabbit started at 1,000 and ended at 2,259. And plant B started at 0 and ended at 0. So hopefully this helps you. You'll go on and answer some questions. And then when it comes to lesson 2, you're going to clear the simulation. So we're going to get rid of everything. So you're going to clear the simulation. And now you're going to do plant A, herbivore A, omnivore A, and a top predator. And you're just going to mix them up to where they can eat whoever and whatever and try to find a balance. And you can keep doing different scenarios until you find a good balance. Do not worry about answering question 1 about predictions, because once again, we're not doing the prediction portion of the table. So you can get rid of this number 1 and this number 1. All right, so finally, this table right here. This is to sum the whole thing up. So simulation 1 was what you did on page 5 right here. And simulation 2 is when you added an omnivore and a top predator. So in simulation 1 was plant A high or low. Same with plant B, high or low. We didn't do plant C, no herbivores. I'm sorry, we did have herbivore A, but no herbivore B, C, or omnivore A, B, or top predator. So you don't need to fill any of this out for simulation 1. But for simulation 2, that's this one, then you're going to fill it out. Now, if you could do some modifications, what would you want to introduce? Would you modify yes, no, drop it, increase it? So you're looking at there. And then same thing, ignore number 1 and do 2, 3, 4. All right, I hope this kind of just helps get the party started. So just for fun, you can really play around with it and put all sorts of things in there. And just see how it does and what it eats. And okay. All right, this concludes it. All right, we'll visit with you later.